Welcome for this session. In fluid power system, we are going to discuss the components and the hydraulic circuit design. In this, course objectives are to understand the concepts of control components in fluid power system and hydraulic circuit. Some of the table of contents are like this: control of single acting hydraulic cylinder, control of a double acting hydraulic cylinder, regenerative cylinder circuit. A hydraulic circuit is a arrangement of hydraulic elements or devices interconnected in such a way that to perform a specific function with a hydraulic system. Design of a hydraulic circuit is to select the various elements, as we all know that the elements and devices of a required type, capabilities, capacities and efficiencies, so that go into the hydraulic circuit, the elements or the devices carry out the intended function. The analysis is the process of verifying the performance of the circuit to build as per the design and specification. To carry out the design, the designer has to consider some of the parameters. That parameters are conformity of the design function, and also level of performance of the efficiency of the each element, and safety and reliability of the each element, and ultimate cost of the whole circuit. Like this, he has to identify. And then main components, main parts of the hydraulic circuits are, as we all know that the power pack, which should be there. Power pack is the just like a heart of the any one hydraulic system, and the control element, power drive unit, system accessories like the pipes and the hose pipes and then different things. Hydraulic power pack is comprised of oil tank, hydraulic pump and electronic the drive motor, and then mechanical couplings, strainers, filters and coolers, etc. This is hydraulic power pack where the mechanical energy is converted into hydraulic energy. Hydraulic control elements. Control elements, as we all know that the various types of control valves and electronics control system to modify the energy, quantity and direction of the fluid. Power drive units are nothing but the which converts the mechanical energy into in the form of work. Power drive units are maybe the actuators and motors. The system accessories are nothing but the hose pipes, fluids, conductors, the filters, may also include the special accessories such as accumulators, power boosters, heating and cooling systems, and additional safety devices. All these comprises of the system accessories. If we come to the hydraulic circuit, all hydraulic circuits starts with a job to be carried out. The job may include the lifting of load, pulling and pushing of load, rotation of the tool head, clamping, declamping of jobs, etc. Therefore, the design of hydraulic circuit starts with the selection of actuator followed by other elements. Means the first we have to select the actuator. Control of cylinders. Control of cylinders means extension and extending and retracting the cylinders, holding the cylinder in the particular position, that is the dwell position, to perform the required work. Extension and the retraction, holding the cylinder in the end, are either extension or retraction. The control of a single acting cylinder, maybe the gravity control or maybe the spring action control will be there. See here in the hydraulic circuit, there is a four-way valve is there. One is manual, the pedal type switches are there. Here four-way, and this is a piston and cylinder, and then one-way control valve will be there. Here there is the strainer and then pump, and then the reservoir. These are the reservoirs. If the pump is sucking the some fluid and then it is passing to the valve, control valve, there it is the maybe the piston, the extension and retraction takes place. Therefore, the loading and unloading maybe happens. Like this, the four-way valve will be there. This four-way valve and the spring action four-way valve. It is going through the valve, and then if the return line is uh, empty, at the time oil will be stored here, and then remaining oil is going to the sump again. Like this, the single acting, the this thing, the circuit, hydraulic circuit is working. Unloading, the unloading valve opens when the cylinder retracts. The end of the extension stroke because of the check valve keeps high pressure oil in the pilot line of the unloading valve. When the direction control valve is shifted, the retraction of the cylinder, the motion of the piston reduces the pressure in the pilot line of the unloading valve. This resets the unloading valve until the cylinder is fully retracted, at which point the unloading valve unloads the pump. This is the unloading valve, the operation we are discussed. Now the double pump hydraulic circuit. Here the two pumps will be there. There is a low flow pump and high flow pump, and then high pressure line and low pressure line will be there. And here there is a direction one-way control, and the unloading valve, pressure relief valve, and then there is the four-way 4x4 valve. There is the retraction and extension. Here you can observe both the side of the piston. There is the fluid lines are there. Again, it is a two pumps, two strainers, and then the oil collection. The tanks are there. It uses a high pressure. Low flow pump is in configuration conjunction with a low pressure high flow pumps. A typical application is a sheet metal punch press in which the hydraulic ram must extend rapidly over a great distance with very low pressure, but a high flow rate is required. Means the hydraulic press. There whenever the sheet metal work is work done, sheet metal work, at the time the hydraulic press is used. There is this type of double pump circuits are used. The rapid extension of the cylinder occurs under the no load. As the punching tool connected to the end of the cylinder piston rod approaches the sheet metal strip to be punched. However, during the short motion portion when the punching operation occurs, the pressure requirements are high due to the punching load. The circuit eliminates the necessity of having the very expensive high pressure high flow pump. When the punching operation begins, the increased pressure opens the unloading valve is valve to unload the low pressure pump. The purpose of the pressure relief valve is to protect the high pressure pump from the overpressure at the end of the cylinder stroke when the direction control valve is in the spring centered mode. The check valve protects the low pressure pump from the high pressure when occurs during the punching operation. At the end of the cylinder stroke when the direction control valve is in its spring centered mode. Counterbalance flow application. Here the counterbalancing is here. You can observe here the piston and cylinder is kept vertically. When there is a load is applied vertically, the no need of retraction. Only the this upward movement needs the high pressure. The downward movement the acts along with the gravity, so that the fast downward movement will be there. Here also there is a four-way valve is used. Again, it is a direction control valve. One is a direction control valve. Only in this direction it will allow. And there is a one more, the valve is there. There is a pump, and then the strainer. There is a oil tank. Here, counterbalancing, as we all know that whenever the cranes and lift, or else whenever the heavy weight is lifted by the anyone, the hydraulic equipment, then the counterbalancing along with the opposite side counterbalancing needed. Otherwise, the machine or the tool may topple. So that counterbalancing circuit is needed. A counterbalance or the back pressure valve is used to keep the vertically mounted hydraulic cylinder in the upward position when the pump is idle. The counterbalance valve is to set to open at somewhat above the pressure required to prevent the vertical cylinder from the descending due to the weight of the load. This permits the cylinder to be forced downwards when the pressure is applied. The open center directional control valve unloads the uploads the pump. At the end of the session, students able to visualize how the control components in the fluid power system works, accomplish the function. These are the references. In the control of double acting cylinder using 4x2 valve. Previous case I used that 4x4 valve. In case of single acting cylinder, extension of the cylinder is due to high pressure of the oil and retraction is due to the either gravity or spring return. But the case of double acting cylinder, both the extension and retraction of the cylinder are due to high pressure. Difference between the single acting and double acting cylinder. When the position 1, if you come to the position 1 and 2, the direction control normal position. At the valve, port P is connected to the B, A to T. In this position, port B is connected and rod and cylinder head end, the cylinder connected to the port A. Here ports are not shown, but these are the ports actually. These are the ports will be there, but ports yes not given in this diagram, but like that the working. The dual position of the cylinder. One more important thing is dual position. See, extension and retraction of the cylinder takes place in the automatically by means of this oil pressure. Some cases, if the counterbalancing is needed more time, means the counterbalance needed the lot of times, maybe more time it has to counterbalance up to the operation is completed. Up to that time the counterbalancing should be there. At that time dwell time is very important. Dwell position of the cylinder is nothing but in the case of double acting cylinder, there may be the 4x4 and 4x2 valve is DC control valve is used. Change its position from the normal to actuated and actuated to normal position, extends and retracts the cylinder respectively. Retention and holding of the cylinder either in the extension, this is the retracted. If you come here, extension. The retention of the or holding the cylinder either in the extension or retraction retraction position during for a particular duration of the time during the continuous operation of the cylinder is called as dwell position of the cylinder. Example for the dwell position is during the drilling operation, number of components and the components are to be held in the job, held in a job holding fixture and then taken out of the fixture after the operation. Another job is loaded on the fixture. The job is secured in the fixture by the extension of the cylinder during the drilling operation, and the cylinder is said to be in the dwell position. Dwell position of the cylinder can be achieved during the 4/3 center position DC valve. Usually 4/3 center position DC valve is used. And then next regenerative circuits, metering in circuit, metering out circuit, a lot of circuits we are going to discuss. All the circuits, usually the flow, quantity of flow is always Q is equal to AV, continuity equation. A is the area and V is the volume, the cross section of the pipe is whatever the pipe you are used. That is the continuity equation that is used for the calculation of the quantity of fluid. Some of these components used in the controlling components used in the the hydraulic circuit is 3/2 direction control valve and 4/2 direction control valve and 4/3 direction control valve. Like these three types of direction control valves are used. Normal position is the position even by the change of the pump is switched on, the oil should flow into the tank instead of actuator. Should flow to the port, the connected port at the end of the cylinder. That is the normal position. Like this, the hydraulic circuits are working. In the next session, we can discuss the other hydraulic circuits.